Check one. Hello, hello, hello. All right. I think we're on. Can anybody hear me meow? Yep. It looks like we're on. Hey, everybody. It's Mike Meyers. Just checking everything. Okay. Hello, everyone, and welcome to the Monday edition of the Mike Meyers Ask Mike Anything live stream. The goal of this live stream is to provide those of us who are isolated by the coronavirus an opportunity to continue our studies on CompTIA certifications. Now, for those of you who show up a lot, and I see a lot of common names, familiar names, the first thing you're probably going to notice is that I'm by myself, and that is because I have been exposed to the coronavirus. And I got a call from a guy like not even an hour ago, and he's like, Mike, I've got the corona. I got corona. It's like, great. And so the bottom line is, I like, Scott, don't come over because we're going to give you more corona. So I am alone today, which causes some confusions because a couple of things that we're going to be doing is I was going to start our big routing discussion today. Between the corona and a couple other issues at Total Seminars, we got a short day today, which is fine. It actually works out beautifully for a number of reasons. Number one, the big thing it works out well is that it gives me an opportunity to do kind of like a pre-routing discussion. I think it's really, really important that we get some base concepts down before we get into too much more depth on routing concepts. But then on top of that, that gives me a little more time to do a better routing thing than what I thought I was going to do. So I think it was, it's just how it goes. Da-da-ba-da. All right. So anyway, guys, this is still going to be relatively short. We will be giving away a voucher today for sure. But we're probably only going to be on for about 30 minutes today. So I apologize for the relatively short day, but we have a very interesting lesson. This lesson is going to be very important for those of you who want to get into routing because I find it interesting. A lot of times people get very confused on what I find to be very basic routing concepts. Okay, JM, I saw you're on. I got your email. Thank you for that, sir. I just haven't had a chance to respond. It has been a crazy, crazy time. So I apologize in advance for a shorter session today. We're definitely doing the routing. I've got lots of people who are very, very interested in the routing stuff. I was very pleased and surprised to see how many people were interested. And we will go ahead and be doing that. Unfortunately, the main part of that will start Wednesday and not today, which just as well, we have a relatively small crowd today. One of the things, before I want to get into anything else, I really want to talk about the concept of Wireshark. Wireshark is the wonderful free utility. It's been around now for over 20 years that allows us to look at individual Ethernet frames. It is a wonderful tool. It is, in my opinion, one of the best teaching tools on networking there is. And if you want to understand networking, if you want to understand routing, you need to understand Wireshark. With that in mind, I'm going to ask everyone, it's not critical that you do it today, but if you could do it today, it'd be nice. But really, let's get Wireshark installed on a system that you can access while you're talking to me. I would like that very, very much. So do keep that in mind. Where does one get Wireshark? I haven't checked the website in a while. So it's wireshark.org. Let me pull that up for you guys so you can see it. But here's a copy of the Wireshark website. Go ahead and just download that and have a copy of Wireshark ready to go, folks, because it is very important. Wonderful tool. Just realized I do not have Teams in any way, shape, or form. Lots of people texting me. Okay, so anyway, make sure you have a copy of Wireshark. All right. Dave, sorry guys, I need to talk to the back office. Dave, Scott, it's going to be hard for me to look at Teams today. Just be warned. All right, so what I would like to do then is, now we at least have an understanding of what Wireshark is, let's dive into this a little bit. In particular, let me just see if we have any questions right up front. Anytime you see me look to the side like that, that's because I'm going through the list, seeing if there's any questions. Lots of Happy New Year's. Happy New Year's back to all you guys. JM passed the network fundamental test, the MTA fundamentals. Going to take Net Plus sometimes this week or next week. Excellent. Sahil here. Edwin. I'm working on COSA Plus and I'm doing test exams. Always good. Everything is going well, but I still make a lot of mistakes. We all do. It's normal. With the incident response objective, any tips or resources on this topic? Not really, Edwin. There's not a lot of ways to simplify the concept of incident response. I guess the one thing I would say is know who's who in the zoo, you know? What does a first responder do and what do they look like? You know, things like that. But that might be about the only thing. Peter Hunt. No, actually, Peter, I was very good. My New Year's Eve celebrations were pretty dull, to say the least. Andre says I have bad hair. I love my hair. What do you mean? The fact that I still have hair gets me excited about stuff. All right. We really do have a relatively short amount of time here today, so I want to go quick. And yes, we are giving away a voucher still today, guaranteed. Probably the only thing we're going to give away today is a voucher. JM, 2:02 p.m. It is 2:07. Can you explain the difference between channel bandwidth in megahertz and channel frequency in gigahertz in the 802.11 standard? All right, so you got to be careful when we talk about, when we say the word bandwidth in any form of IT, we're really trying to talk about the amount of data that can be accepted through that particular channel. So for example, a piece of copper wiring can have a bandwidth to it. Cable modems have a bandwidth, and that's usually more of a bits per second kind of thing. When I see someone say channel bandwidth and they say megahertz, that might be one of those few cases, JM, where we're talking about the actual width of the channel, which doesn't happen a lot, but it does happen in 802.11. With 802.11, what's going to happen is that you're going to have, oh man, there's a wonderful diagram for this on Wikipedia. Let me see if I'm not going to be able to pull it up fast enough to answer it. In the world of radio frequency, we use the term channel because if we told you to tune into 2.436254115 megahertz, you'd be confused. Please understand, folks, there are no channels in 802.11. It's a bogus, made-up human thing because when we're dealing with human beings, we don't want to tell them to tune their wireless access points or their wireless NICs to 5.231265 whatever hertz. That'd be gigahertz. So we come up with this fake concept called a channel. So a channel is nothing more. So let's go with the 2.4 gigahertz ISM band. When we talk about a band is a range of frequencies, okay? And I don't have these numbers memorized off the top of my head, but there is, you know, and I'm going to make this up, but it's like 2.41 blah, blah, blah to 2.48 blah, blah, blah. That whole range of frequencies is available for the 2.4 gigahertz ISM band, okay? So in this case, what we're talking about, when we say the word gigahertz, we're talking about a range of frequencies, and that being the bands. So it's measured from the lowest gigahertz to the highest, okay? So in that case, we have a whole bunch of, now within this entire band, which is the entire 2.4 band, we have a number of preset frequencies that we call channels. And they're done to make our lives easier, theoretically. So here in the United States, for example, we have 11 preset channels. Folks, these channels are completely fake. Do you understand? The committee that invented this decided to break them up into these channels, and this is what they picked. Moderate, some degree of arbitrariness, to be honest with you. Okay, so that's when you talk. So now, within these channels, you don't see this very much in the 2.4 band, but in the 5 gigahertz band, what you'll see, depending on what version of 802.11 you're running, is the width of the channel. So even though the channel, you would think the channel is just one frequency, but it's actually not. If you talk about how 802.11 uses really spread spectrum type technologies, OFDM, orthogonal frequency division multiplexing, even within that one channel, there's a bunch of little sub-channels that are all working together to get your YouTube video to you on your smartphone or whatever you happen to be using in a wireless way. So inside of this channel, you have lots and lots of little sub-channels. Nobody cares. Nobody wants, the only people who even talk about this are like the nerdiest of nerds. From a get the wireless network running standpoint, as long as you tune to the right channel, everybody's on the right channel, life for good. In the 5 gigahertz band, channels are automatically tuned, so that makes life even easier. However, there is a situation, particularly starting with like 802.11n, 802.11ac, 802.11ax, where your one little channel can be maybe only 20 megahertz wide, or it could be 40 or 80 or even 160 megahertz wide. The reason they do that is that allows you to have more subchannels, and therefore you can send more data. The downside is that the wider your channels are, the less other people are going to be able to play in that 5 gigahertz band. Do you understand? This is one of the big things that always gets me excited about people when we start talking about setting up wireless. Because everybody's like, I'll just go wireless, throw a stupid wireless access point, or even worse, a home router in my house, and I don't even bother looking whatever the heck else is out there, which is insanity. With 2.4, it's not too bad because you do actually have 11 channels and there's ways to cheat, and you can even get 2 more than that that are undocumented. But to just slap a 5 gigahertz receiver that's running, like, let's stick with 802.11ac. To just slap that into a noisy environment is insane. Now, will it work? Yes, but here's where people really get messed up. Because the first time I started telling you guys that you can take individual channels and you can take them from 20 megahertz and make them out to 40, and these settings are right there in your wireless access point. They're there. Look. Okay, and you can say, what channel width do you want? The wider the channels, in general, the more data you can move. So a lot of new people are like, oh, I'll stretch it out to 160, but people love to catch me when I say things wrong. If you have very wide channels, you are eating up a huge percentage of the 5 gigahertz band, and other people around you are going to hate your guts. So what we often do in those particular situations is we use narrower bands, even though we have the ability for more, just because it's a busy environment. And this is one of the things that's very important for us to be able to do site surveys with wireless, to at least get some kind of idea of what we can or can't do. Now, I realize, Jam, I probably haven't even answered your question, so let me get back to it. Can you explain the difference between the channel bandwidth in megahertz? I think I've done that. And channel frequency in gigahertz. Okay, to make it easier, so the bandwidth, the total, I've never heard the term channel bandwidth, JM. I wish you could give me a source, because I think you using the term channel bandwidth is inaccurate, but that's I don't want to get in trouble. The individual channels themselves have a range of frequency, okay? Even within a single channel, it's going to have a starting and an ending frequency, and then within that are going to be subchannels. Channel frequency is whatever. So even every channel is going to have a range of frequencies. When we usually say the word channel frequency, we tend to be talking about the very, very first one. I'm going to make a quick attempt to find a wonderful Wikipedia article that goes into this in wonderful detail. I may have found it. Look at me. Who's the lucky guy today? Mike Meyers. Yes, he is. Okay, let me bring this up for you. Okay, so this is straight from Wikipedia. So this is the 2.4 gigahertz, so 802.11b, G, N, and AX. All right, so if you take a look at this, you see F0. So that's going to be middle frequency of that channel. So channel 1 actually goes from 2401 to 2423. You get that? So that is a, what was the term you were using, JM? I want to make sure I want to use your term here. This is where I think where you would be talking about the bandwidth. So you can see that's actually a range. And within that are a bunch of sub-channels. Okay, so, and there you can see how they overlap and all this is all pretty well known. So you can see each one of these channels is 22 megahertz wide. Get that? So I guess that might be when you say channel bandwidth. All right, so let's get out of the 2.4. Let's go to 5 gigahertz, which is a lot more interesting. 5 gigahertz is a huge bunch of channels. So you can see it starts here as low as 5035 and goes up to big. These are all the different channel numbers. They're nonlinear. Keeps going, 5.8, so about 5.9. A lot of these are weird channels that are not super common. But if you take a look at these channels, like let's just pick one in particular. Here's channel 165. Its median range is 5825. It goes from 5815 to 5835. But notice this is the 20 megahertz version of that. If you want 40, here's the 40 megahertz. What you're going to end up doing is you're going to eat up channel 165 and 169, which are two 20s, and you're going to instead channel 167, which defines a 40 megahertz wide channel. Get the idea? And then here's even an 80, and there are in some cases 160 megahertz wide channels as well. Woo! Okay, so hopefully that answers your question a little bit. Hang on. The whole world is trying to communicate to me. All right. So that was an interesting question, JM. All right. Does my hair look that bad? I guess it's a little shaggy. I'm probably going to go back to shaved head here pretty soon. Okay, let me get back to where everybody is. Linda Wen. I think you're new, Linda. I haven't seen you before. Welcome. Esteban, Darius. Oh, we got some names I don't normally run into. Colonel Panic. That's a good name. Do you need a voucher for each half of the A+ certification? Yes. You don't need a voucher. You need to pay for each. Your phrasing is bad, Colonel Panic. Let me fix you. The A+ certification consists of 2 exams, not halves. I know it's semantics, and I'm not picking on you personally. There's 2 exams. You have to pay for each exam. If you're using vouchers, then you need 2 vouchers. How's that? Okay. Ben Adams. Hey, Mike, I have buddies tell me to skip A+ if you already have a position on the help desk. Any thoughts? Ben, I always tell people that the reason you're taking a certification for your next job. And if you are on a help desk and well established on a help desk and don't have an A+, unless you're continuing to look in the help desk world, or maybe you want to get into systems or something, then yeah, I would probably agree. Go for a Net Plus. Move along the chain. Oh, it looks like everybody answered Colonel Panic already. Look at that. Okay, a couple of things just so you guys know. Number one, at 2:08 p.m., I'm running low on time today. At 2:08 p.m., Dave Rush posted our Discord link. Please give our Discord link a chance. Check them out. It's a bunch of good text on here. A lot of the names you see here are on the Discord link at all. This is not my Discord. I have no control on it. Okay? So if somebody's saying bad things to you, it's not mine. I can't shut it down, nor would I really want to, but it is more of a private thing. But do check out the Discord. In particular, man, if you got a headset and a camera, you really want to start meeting some of these people. Andre's not attractive. I'm just going to warn you, but he's a good guy. Thank goodness we have, prettier people like me showing up. But do check out the Discord channel. We tend to have the biggest crowds there immediately after an AMA. So you keep that in mind, but it's a 24/7, and you don't have to have a camera if you don't want to, or you don't have to have a headset. Just type in. Anything is fine. Check us out and say hello. All right. Let me, real quick, because I have such a short day today, I want to talk for a minute and cover the idea of I got some very interesting questions when I was going to start routing, and I need to get some what I consider very core stuff to be cleared up. So guys, what I want you to do for starters is imagine a world where you just have one little switch and a bunch of computers around it. These computers, in order to talk to each other, need some kind of addressing system. And that addressing system is usually what we call the MAC address. So let me bring that up for you guys real quick. All right, so let's take a look at this. So here's, I'm hoping you guys can see this. All right, so what I'm going to do is I'm going to route ipconfig. Now, ipconfig by itself isn't going to be too much use other than to let you know I've got a lot of computers around here. In particular, I have a connection that I have called Ethernet. So let's do this again, except I'm going to do ipconfig /all. All right, now when I run it this way, this is all, I've got a lot of network cards in here, folks. Okay, there's the ipconfig /all command. It's my studio system. Okay, so where'd it go? There it is. All right, do you see where it says physical address right there, folks? Do you see this hexadecimal? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 4, each hexadecimal represents 4 binary. There's 12 here times 4 is a 48-bit address. That is the MAC address. MAC addresses are built into every network card, whether it's a physical Ethernet or an 802.11 or whatever, there's a MAC address built into it, okay? And if our entire universe consisted of nothing but disconnected little local area networks, you ready? We wouldn't even need routing. We wouldn't even need IP. Is that crazy or what? If you go way back into the mid-1980s and you look at what Microsoft was doing with networking back then, Microsoft thought a network was going to be just a group of people who work together, a work group. And this would rarely be more than 20 people. And the only two things a network would share would be folders with files in them and printers. That's what networking was for as far as Microsoft cared. Okay? Now, if you go back into the 70s, early 80s, then you have a bunch of these guys running supercomputers in the universities, and they want to start interconnecting because people don't like to have to go to the computer. They want the computer to come to them. So remote terminals was a really popular thing for a long time, but sometimes we wanted to actually access the resources, whereas a terminal is just like a terminal. So they began to create a whole other type of networking, and in that case, data to be shared was going to be stuff, well, files for sure, but then other things would be shared with things, weird names that we'd never thought about before, with like names like email. You know? What the heck is email? Anyway, our entire universe of networking grew up with two really competing ways to look at what networks are all about. And what I want to do for right now is let's go back to the Microsoft model, because the original Microsoft model, it used a computer naming system called NetBIOS. And in order to make NetBIOS work, and this is the important part, you have got to understand this or you will never understand routing. You ready? When you just have a small number of computers and they're all hooked to basically just one switch, you can broadcast to find out other people. Folks, this is critical. Understand what a broadcast is. A broadcast is a Ethernet frame, or I mean, technically it could be a packet, but let's stay with frame for a moment, that is sent out in such a way that every single device on that same switch can hear it. This is what we call a broadcast domain. A single switch makes a broadcast domain. Say it with me, people. A single switch makes a broadcast domain. Well, Mike, what if we had two switches daisy-chained? Okay, then two switches daisy-chained together can make a broadcast domain. Do you get the idea? A broadcast domain means if somebody sends out a broadcast, who can hear it? Anybody who can hear it is in the broadcast domain. Let's hear it from the balcony. All right. It's really important. Do you start to get the impression why? Because if you don't know what a broadcast is from a unicast, we almost have to stop there. So let me give you an example. If we have a small network, I can do some cool things. Like, for example, I can send out an Ethernet frame. Now, this frame, the MAC address is all Fs, 12 Fs, all ones. And that means a broadcast, okay? So everybody gets to hear that particular frame. It goes out to everybody. And with a broadcast, we can do some cool things. And by the way, if I'm sending a frame just to one person, we call that unicast. Just to one system, we call it unicast. So we have broadcast and unicast. There's other stuff, but I don't want to go into it right now. This is very cool, people, because I can do things like, hey, whose computer, or you could when you boot up, you go, hi, my name's Computer Mike. And everybody else in the network will respond going, hi, Computer Mike. And they'll write down, Computer Mike is at MAC address, da-da-da-da-da. Get the idea? You can only do this with small networks that you can broadcast on. And that is the problem with Microsoft networks. It always has been the problem. And that is Microsoft networks don't have any protocols in them that allow for lots of little networks to hook together. One more time. Microsoft networks never really came up with a way to allow lots of little networks to connect to each other. If you want computers to speak in a LAN, you connect to them with a switch. The switch filters and forwards based on MAC addresses, just like the one I just showed you. Are we okay with that? The problem is if you want to start talking to lots and lots and lots and lots of people, where you start adding more and more to the switches and more, there's a certain point. That number's not as big as you think either. There's a certain point where there's just too much broadcasting going on because these things are constantly broadcasting to each other. And this still happens to this day. So we have to separate our switches into these little groups called local area networks, and we interconnect our LANs with these things called routers, okay? So I only want to do one more thing today. And that is when we set up a computer, we set it up with an IP address. Now, that IP address might be coming from a DHCP server. I don't know where it comes from, but we have some kind of IP address. So let's take a look on my system here. Let me clear this out. Okay, so what we're going to do is run an IP config. And let me scroll up to where it is. All right, so I'm going to be using IPv4. So right here, folks, please remember this number. Grab a pen. 172.18.13.120. Does everybody see that? 172.18.13.120. That is my IP address for this computer right here. And my router is 172.18.13.1. Got those numbers in your head? Because here's what's going to happen. Most of the time, when you're on a local area network, forget the router, people. You just got another computer next to you and you want to get a file or something like that. You don't even really use IP. You don't. All you use is the Ethernet part. So let me show you how this works. It's actually kind of fascinating. We use something called ARP, okay? So let me bring up ARP for you. Oops. ARP is one of those super important commands that we never really talk about much because, well, we just never do. Okay, so I'm going to type ARP. About the only typing ARP by itself is sort of meaningless. So what we do is when we do ARP, we tend to do ARP with some kind of switch, and by far the most common one is A. So what that is showing us, folks, when you do an ARP minus A, remember what my IP address is for my NIC here, right? These are other NICs that are doing other things. Ignore them. So what's happening here is because of ARP, it has a list. You see all these IP addresses for my network, and it has the associated MAC address. Dynamic means that it's asked for all the time. Static means they're kind of built in. So, like 172.18.13.1, that is the MAC address for the network card inside my router, or one of the network cards, the one that's connected to the LAN part. And that becomes very, very important. So yeah, there's other ones in here. ARP resolves IP addresses to MAC addresses. Just get that in your head. Because most of the time, when you're trying to connect to another computer, it doesn't know what the other guy's MAC address is, but it probably knows the IP address. So what happens is if you have an IP address, now when I say you, I don't mean you personally. I mean your Windows system or your Linux box or your iOS phone or whatever is doing this for you. They send out ARP requests. And they're basically going to go, and these are broadcasts. And these broadcasts go out to the entire local area network and they go, okay, whoever is 172.18.13.22, please tell me. And then when they respond back, then we get your MAC address. We put the MAC address into the cache like you just saw with the ARP-A, and for about 2 minutes, we have a lot less ARPs. So what I want to do is, first of all, I want you guys to see an ARP. So let's do this. Oh, it's so small. I'm going to try to make this a little bit bigger before this is Wireshark I'm pulling up, guys. Bear with me just a minute, kids. Is there a view? View. Full screen. You're going to zoom. I'm getting it. Just bear with me. All right. So what I've done is I took my Wireshark and I've got it zoomed up a little bit so everybody can look at it. All right. So let's take a look. Bring that up. All right. So this is my Wireshark capture. There's lots of stuff in here, but you'll see these ARPs. In fact, let me filter that. ARP. Okay. So now all you see are ARPs. So if you don't know how to do what I just did in Wireshark, at the end of this talk, you need to fire up Wireshark and practice some captures and practice filtering. In this case, I'm just filtering the Wireshark on ARP because I don't want to see anything else. All right, so basically what I have here is there's some device called Amcrest. These are my cameras, and they're broadcasting an ARP command out. There's other stuff in there. I don't even know what these are for sure. But Black Man, oh, this is, yeah, I know what that is. Okay, so anyway, the bottom line is these guys are sending out ARP commands, and they're trying to figure out stuff like who has 172.18.13.120 tell 172.18.13.7. So that is a sample ARP command. As you can see by the quick little demo I did with Wireshark on my little tiny home network, there's lots of ARPing going on. Now you would think to yourself, well, Mike, why doesn't it just ARP once, get the MAC address and keep it? Because stuff changes. And we don't know what will change and not change, so as a result, ARPs tend to go on after a while. You saw when we ran the ARP command in Windows that it said dynamic and static. The dynamic ARP registries are ones that came from those ARP queries. Static are the ones that are kind of built into Windows, and yeah, so pretty straightforward. So in your local area network, your brand new 2022, God, didn't that sound like a Buck Rogers space date? Even today, we lean on the archaic but perfectly functional ARP command to know where everybody's MAC address is. Isn't it funny? We spend so much time working on networks, configuring IP addresses either statically or dynamically and all that. Do you guys realize that an IP packet, so an IP packet where the IP2, IP from, port numbers, data, frame rec, all that stuff, that is never seen by itself. IP packets always have some kind of frame on the outside where it's going to have a MAC address to or MAC address from. Even things, that's just Ethernet, folks. DOSIS, all kinds of other technologies that still exist out there have something similar to that. IP packets do not exist by themselves. The only time an IP packet exists by itself is inside a router. And that's where I'm going to leave it for Wednesday. I want to make sure that we're comfortable with the concept of ARP. Please fire up a Wireshark and play with it a little bit. And what we're going to do when I see you on Wednesday, we're going to be doing some demonstrations of how a router routes. And I want you to keep in mind that a router, IP packets only exist by themselves inside a router. And I'll explain how that all works come Wednesday. All right. Well, that worked out. Oh, it's 2:30. I'm going to run out of time. But I'm giving stuff away. Okay. Guys, we're going to have to wrap it up. But what we're going to do first, let me run. Make sure there's no critical questions. JM, I swear, you need to hang out with me sometimes. I'm going to stretch. I think I can stretch for a few more minutes. The bearded IT dad, what about layer 3 switches? A layer 3 switch is basically a router. A regular switch that we know and love is a layer 2 switch. If we're looking at the OSI, a switch filters and forwards based on MAC addresses. A router filters and forwards based on IP addresses, but we really haven't got there yet. And Dave Rush has given some nice answers there, so I'm going to let you guys deal with this. No. TC, oh no, Mike showed his IP address. Is he worried about hackers? I am not worried about hackers. And that's my internal IPv4, and I don't think you guys are fast enough to get my IPv6s. And if you did, my firewalls would stop you. And if you really needed to hack my stuff, just call me up. I'll set up a Hack Me box. I'm always glad to do that. You guys are so worried about my IP addresses. We're okay. The bearded IT dad, does ARP work the same in IPv6? No. In fact, in IPv6, you don't really have an ARP. But bearded IT dad, will you please put a pin in that question? I want to do routing from an IPv4 standpoint first, and then we would come back and we can do it again through IPv6. Actually, routing is a lot easier in IPv6. Thomas Robinson, Mike, is there IPv8? Not that I'm aware of. What's the difference from video training and... What? What's the difference from video training and simulations? Okay. So what's the difference? These are terms that we tend to use here at Total Seminars. When you take a CompTIA exam, you have regular multi-choice questions, and then you have, performance-based questions. Performance-based questions theoretically make you try to do something somewhat fairly real world, and then you do it. Here at Total Seminars, we separate those training materials. We have practice questions that mimic the multiple choice questions, but we also have what's called Total Sims. So what we call Total Sims are the example performance-based questions. So that's all that means. Justin Krause, what about IPv6 for ARP? Ooh, okay. You guys ask very interesting questions like this. Okay. I'm trying to figure out a way to do this in my limited time. Yeah, Justin, bearded IT dad, I'm going to have to save those IPv6. Those are fascinating questions. And I actually think we did a pretty good one on that already that we can attack. Dave Rush, did we not do a wonderful IPv6 video last year sometime? Oh, look at that. Dave Rush already has it. Oh, that's for ARP poisoning. Okay. All right. Again, guys, I'm running very low on time today, so I'm going to, and I do want to give away a voucher. So let's go ahead and give away a voucher. So we're about to give away a CompTIA voucher. This voucher works anywhere in the world. That if CompTIA gives exams in your country, it will work there. These vouchers work for any CompTIA test. So IT fundamentals to CYSA plus, whatever you want, it will work. If you're going for the A+, you would need 2 of these, okay? So here's what we're going to do. I'm going to ask a question. And the person who answers it, you ready? Best is going to win, okay? So I'm going to ask a question, and the person who answers it best is going to win. Now, I have 2:41 local time, so I'm going to give you guys 2 minutes to answer this question. And whoever gives me the best answer in that 2-minute window, and by the way, folks, if I say the 2 minutes is over and you don't think it is, I win, okay? So let's go ahead and give this a try. This doesn't have to be a big, long, hairy answer. In fact, the best answer will not be a big, long, hairy answer. Here is the one. Everybody ready? Just type it into the chat, okay? And I'm going to call it. You ready? What does ARP do? You have 2 minutes to answer this question. What does ARP do? I've described it multiple times here in the last 15 minutes. What does ARP do? Mr. S tells me what it stands for. Bearded IT Dad being a smart aleck. Got another 90 seconds. Go ahead, guys. I'm going to finish my Gatorade Zero. Grape drink. I need that Jeopardy music right here. Do, 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 do. Do, 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 boo, boo, do, 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 do. All right, we've got some answers here that are good. Colonel Panic, whatever you ethically needed to do. That's not true, but it's still funny. Okay. The answer I was looking for was pretty straightforward, folks. I even had already said it. But it was it's a particular verb I wanted to hear, and that is resolves. ARP resolves IP addresses to MAC addresses. It doesn't translate, it doesn't convert, it doesn't connect. It resolves. Now, we didn't talk about how it resolved. In fact, Bearded IT Dad gave a nice explanation of how it resolves, but this is what I was looking for. I wanted the word resolves. And I'm going to give this to, today's winner is going to be Eugene Hunter. Now, guys, normally I've got a bit of a panic on these types of things because I don't like giving them to the same people and over again, but I'm a little bit out of communication with Dave Rush and the guys today, so I'm just going to go ahead and call it. And Eugene Hunter, I'm going to give it to you. Dave, I hope Eugene Hunter is a qualified winner, but we're going to give it to him no matter what. Eugene, congratulations to you. You have won a CompTIA voucher, which is worth up to $400 depending on who you're talking to. Now, Eugene, in order to claim your prize, you've got to jump through a couple of small hoops. Not too bad. But the first thing you're going to have to do, Eugene, is you're going to have to send an email to Dave Rush. Eugene, I hope you're taking notes. Eugene, send an email to daver@totalsem.com. By the way, Eugene, don't be in a panic. Dave Rush will put the same information into the chat window. You can always scroll back later if you need to. However, Eugene, within that, First of all, you have to have your YouTube name. Whatever name I'm seeing there, which is Eugene Hunter, needs to be in the body of the email. We need your email address in the body of the email. You may, but Mike, I'm sending you an email. Just use my return address. Nope, because we've tried that before, and people write this wrong things in, or they do something confusing, and then all of a sudden, like, we didn't get our stuff. So we have to go through this step. Put your email address in the body of the email. Okay, next. Your exact name is on previous CompTIA certifications. And every time you have to take a CompTIA certification, you have to use the same name over and over again. Like me, it's going to be Michael D. Meyers. If this is your first certification, then pick one, all right? Pick, Eugene Dempsey Hunter or whatever your middle name is or something like that. Next, make sure you put the country where you reside. And if you're in the USA, you Americans have to put your state in as well. Texas, yeah! Second to last, take the country where you will take the exam. Now, for us Americans, that's not much of a deal, but for your Europeans who can, cross the street, and next thing you know, you're in Luxembourg, where you can jump your countries easily. Be sure to make sure your country's in there. And then last, and certainly very important, put the exact exam number. Like if you're taking the A+ 220-001002, put that. Don't put just A+, because that's not going to do you any good. So be sure to add all that information. Eugene, congratulations to you. All right, guys, we're going to go ahead and wrap it up early today. I apologize for the short day. I blame the corona. I can still smell things, so I think I'm okay. When we come back on Wednesday, what we're going to be doing, guys, is we're going to be looking at how the concept of routing works. If we're going to have these two networks, two local area networks, each with their own switch, we're going to interconnect these things with a router. And we're going to show you how routers interconnect local area networks to make a wide area network. So on Wednesday, we're going to be covering what I'm going to call static routing and the basics there. And then we're going to come back next Wednesday, and then we're going to start talking about dynamic routing. And I don't know how deep I want to go into that. So what I need you guys to do is send me some emails. Send me an email here. It would be extremely helpful to me if you have questions about routing that you want to talk about, okay? And your questions will help me decide how deep I want to go into this. I can easily do a 3-month, 8-hour-a-day program on routing. I'm not even being a smart aleck. It would be very, very practical, and we would bore lots of people who are trying to pass their Security Plus or A+ or whatever it might be. So help me help you by letting me know some of your burning questions. Send those to me in an email, and then that way I can look at them. Let me put that up one more time for you. michaelm@totalsem.com. And I think we'll have a very, very exciting and interesting routing class. But I think that's all we got for it, guys. I'm sorry about the slightly short session today. It's not that bad. We're only 10 minutes fast. I will be back on Wednesday. And until then, folks, I am out of here. This is your Uncle Mike saying good night. Good night.